All right, I'm going to use this video to give you an example of a homework problem. Okay, and each of these ask some slightly different questions, and you have to be able to work with the question. All right, so the first, this shows movie prices from 2001 to 2010. A says make a scatter plot. I am going to use my calculator to do that, but I am going to say that X is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So X represents the number of years after 2001. All right, so I'm going to make a scatter plot. I've already input the data, so I'm going to go zoom, stat, and we can, sketch it. It's going to be something like this. Looks like it can be exponential. So if we have a model here, f of x equals a b to the x. Use a first point and another point to approximate the model for the average ticket price. So the first point is 0, 5.66. If I just use the second point, 1, 5.81, remember, we take this number divided by this number. If we use another point down here, we'd have to divide by that number to some exponent, right? So our approximate exponential, if I just use this first point and second point, looks like it's about 1.03. So this is a B if I approximate it using the first point and the second point. Now, if we graph a model, remember, if this is 1.03, I'm going to use that first point, 5.66 equals A 1.03 to the 0. That means A is 5.66, right? So if I go ahead and graph y equals 5.66, 1.03 to the x, I'm going to see how well it fits my data. All right, 1.03 to the x. I'm going to graph it. Really doesn't fit it very well at all. What did I do wrong here? Oh, I didn't raise it to the x. That would be a problem. So if I do this, now let's see how well it matches. Wow. It does this. It does this. Okay. All right. So that's if we use the first and second point. Then it says, B says, use a graphing calculator to find the regression model and then graph that. So I'm going to do stat, calc, go down to 10, right? Go down to calculate, and the regression model looks like this. Y equals 5.58. Wow, 1.03, I'll do this. 69 to the x. Not terribly different. So now I'm going to graph that, and we'll compare it. 5.58 times 1.0369 raised to the x. Now this one I wish I could do in different colors. Really follows it pretty well. Whoops, till about the last point. So it's definitely a better fit. And we used all the data points to get this regression model, not just one. Okay. Then C says, what does the regression model predict for the average cost in 2014? So 2014 is how many years after 2001? 13. So I'm going to say y equals 5.58, 1.0369 to the x, which will be 13. So I can calculate it this way. Times 1.0369 raised to the 13. 8.94. The other place I could look is on the table, couldn't I? At x equals 13. I go to my table, and I go down to x equals 13. It's the same number, 8.94. Okay. Now, a theater owner uses the model in 2010 to project income sales for this. If the actual price is this, did he make a good business decision? Actually, no. His model aired higher, right, than what turned out to be the actual. But remember, you only have the data you have to try to make these predictions. So he aired on the high side, but it's because that's what the data was showing. And he tried to get a model. And why do we get a model? To predict. All right, I hope this helps you with the rest of your homework problems. Thanks.